So primitives allows us to store simple values, i.e. whole numbers, decimal values, characters, and in here you can see the list of them. So boolean, byte, short, char, int, long, float, and double. Now, what is the difference between all of these? Well, the difference is that, for example, if you take double and float, so these allows us to store decimal values, but float allows us to store bigger numbers, therefore taking more space in memory. Let me show you the table. So have a look. So we have the type, the size, minimum, maximum, and there's an example in here. So byte in here, the minimum number that it can have is between -128 and 127. So within IntelliJ, if I create a byte variable, so byte, and I'm going to say n equals to 127, have a look. So this works, but if I say 128, it doesn't work. So I cannot fit a number bigger than 128 into the byte variable. So here, the next data type that allows me to store whole numbers bigger than 128 is a short, right here. So short, and short. So if I show you, have a look, minus 32,000 plus 32,000. So as soon as I say a number, for example, 40,000, for example, so 4000, I cannot store a number bigger than 42,000. Or actually, just 33, right? So I think it was 32,700, I think. But if I say 33, I cannot store right here. And the next data type that allows me to store whole numbers bigger than this is int. So have a look, int. So int now allows me to store really big numbers. Also, if you want to store numbers bigger than this, so this is the maximum here, you can use long. So these allows us to store, so byte, short, int, and long allows us to store whole numbers. Then we have float and double for decimal numbers, and you can see the minimum right here and the max as well for both sides. And then we have character and boolean. So boolean allows us to store true or false values, nothing else. Now, generally speaking, you will never use byte nor short, and most likely int all the time. If you need bigger numbers than this right here, you should use long, and then double. So float or double for decimals, characters, and boolean. And the reason why you've got these data types in here is because before we used to have a constraint on the memory RAM. So people used to code these programs, and because they didn't have enough storage on the RAM, then they had to use these data types. But these days, this is not an issue. So in my case, for example, my RAM, so I've got the Mac M1 Pro, and I've got 32 gigs of RAM, which is not an issue. And have a look at the size in here. So this is bits. So 8 bits is 0.125 bytes. So this is literally nothing. So integers right here, so 32 bits is 4 bytes. And again, this is literally nothing. And if I show you the conversion, and in this website, it gives us the computer storage unit, so smallest to largest, bit is an 1/8 of a byte. So have a look, byte, 1 byte right here, a single byte stores 8 bits. So this is what I was showing you in that chart. So a kilobyte equals to 1,000 bytes, megabyte 1 million bytes, gigabyte 1 billion bytes, and then we have terabyte, which is 1 trillion, so on and so forth. So in my case, I have 32 gigabytes, i.e. 32 billion bytes. So if I have a bunch of these variables, for example, an integer, then basically you can see that these days memory, it's not a problem. But these are primitive data types, and they allow us to store simple values.